Hello and welcome to this tutorial on queries. In this tutorial we're going to talk about what queries are and how they work in iDesktop. So let's get started. So this is how this tutorial will go. We will talk about each of these first, and then we will do some exercises to get a better understanding of how they work. So let's start off with simple query. So simple queries allow us to browse associated attributes. Now what the associated attributes table does is that it builds a linkage between spatial data and attribute data, and it is dynamic and simultaneous. Using simple query, we can query objects' attribute values, spatial infos, and nodes. Finally, we can query the node's spatial information of a polygon object. So let's see how these are done in iDesktop. So this here is our world data source, and we have our world polygon dataset right here. And in order to view its attribute table, we are going to right click on our polygon layer, and we're going to say associate attributes. Now here we can see that they're both related, and whichever item we select from the attribute table, it is going to be highlighted in the map as well. So as you can see, we can select different items and they will be highlighted on the related map as well. So in order to check the properties here, we're going to select a polygon and we're going to say properties. And here in the properties, as we talked about in the slide, we can see three items. One is the property, and here we can see the general properties of our polygon that we selected. And under the second one, which is spatial info, we can see some more information which contains the basic information and bounds of this particular polygon. And finally, we have nodes which show the x and y values of the individual nodes that make up this polygon. So we can go in and we can actually view these different nodes. And we can go into Object Operations ribbon, and under Object Editing, we can say Edit. And here we can see all the individual nodes that make up this particular polygon. So as you can see, by selecting a node value, we can actually move between nodes. So the next type of query is called Spatial Query. Now, Spatial Query is a query method that selects map features based on their spatial relationships to other features. Currently, 8 spatial query operators are supported, which are cross, contain, within, overlap, disjoint, touch, identity, and intersect. Now, here we can see some of the examples of some of the application examples that require spatial query usage, and they are which countries are located on the equator, for example. The Yellow River passes through which provinces? If a road needs to be widened, which houses should be removed? So let's go ahead and see how spatial query is used. Now, in order to do that, we're going to do some exercises. And the first one of those is going to be finding the world countries that are located at the equator. So let's go into iDesktop and see how that works. Right, so for this demonstration, we have our world data source open, and within our world data source we're going to open our world data set, which is open right here. And before we go ahead and run our query, we're going to select our grids line data set, and we're going to drop it onto our map as a guideline, and this will tell us where the equator line is. And we're going to go ahead and make sure that this layer is selectable, which it is, and we're going to select the exact middle of the grid here. So let's go ahead and count the boxes so we know where the midpoint is. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right, so we have 12. So it should be at 6. 3, 6. So this is the exact middle of the grid line, and that will be the equator. Now, what we want to do with this exercise is that we want to find out which territories or countries lie on the equator line. So we're going to go under spatial analysis after selecting this grid line, and we're going to go under spatial query, and we're going to say 2D spatial query. Now we're going to select our polygon data set here, and under spatial query condition, we're going to say cross line region. because we want to see which regions does this line cross, and we want to select all of those regions. So we're going to say that, and we're going to save our results. Let's leave the names as is, and we're also going to browse our attribute table, and we are going to highlight these on the map. So we're going to say query. So there we go. All the countries on the equator line have been highlighted and their attribute table has been created as well. Now, in order to take a better look at this, we're going to open the Spatial Query for polygon dataset that has been created using that query. So let's see what it looks like. So we open it up and all the countries that lie on the equator line have been selected using that. And that is how the spatial query works. Now, the next thing that we are going to work on is a little bit more complicated than the previous one. We're going to query which rivers intersect with the Chinese international boundary. The second step is to get those rivers in China by making use of overlay analysis. And finally, we're going to sum up the length of the Chinese rivers by a statistical function, and that is going to give us the combined length of all rivers that are in China. So let's go ahead and do that. Okay, so for this demonstration we have opened the world data source from sample data. So in order to do that, you go into File, Sample Data, Maps, and World Map. And from within this data source we have opened up the world polygon. And on top of this world polygon, we are going to drop the rivers line dataset so that we can see all the rivers. And in order to make them more prominent, we're going to go into layer styles of our line layer. And we are going to make them a bit wider. And let's say we're going to change their color to not a blue, because when you run a SQL query, the color of the selection is blue, so it is going to get confusing. Let's say we're going to make them white so that they're more visible. Right, let's close this up, and we are going to select China, and we're going to go under Spatial Analysis. We're going to say Spatial Query, 2D Spatial Query, and over here we're going to select our line layer this time. And under Spatial Query, in front of the line layer, we're going to say intersect region line. We're going to save the results of this query, and we're going to browse our attribute table and also highlight it in the map. So we're going to say query, and as a result of this, all the rivers that flow into China have been selected. Now, the next step is to isolate these rivers from other countries. We're going to go under Spatial Analysis, Overlay Analysis, and in here the inputs are going to be the spatial query result that we just saved, and the overlay dataset is going to be the China polygon, so that the spatial query result is limited to whatever part of the result is within the limits and bounds of the China polygon. So let's say OK, and we're going to open up the China polygon in a new map, and we're going to drop the clip result, which we just saved from the overlay analysis, onto it, and we see that it has been limited to within China. Now, if we browse its attributes by going to its layer and saying associate attributes, we can see how long these rivers are. Let's say we select the length of these rivers in kilometers, and under the attribute table ribbon, we select sum in order to calculate the total distance covered by these rivers. And sure enough, the total distance in kilometers is shown here. So that's how you do overlay analysis. Right, so the next step is a SQL query. Now in this exercise, we are going to construct a SQL expression to query spatial and non-spatial data. Now the specific example is going to be that we are going to be querying the countries whose population is more than 100 million, and we are going to be storing the query results in a new data set. But before we do that, we're going to talk about the SQL Query Parameters. Now these are the parameters that we have. We have query mode, and then we use a select function, We use where. We use sorting, whereby we query the results that would be ordered by this specific field. Then there's grouping, in which we can either specify the fields to be used to group the query results, and the records with the same value in the specified field will be grouped together. And the other is to use attribute-only query mode, and the group by field would divide the table into several types, such as using state name as group by field. However, the SMID field is not recommended to use because this is a system field that is used as an index. And finally, we can show the result. What this does is that it opens the dataset in a map window before querying so that we can use the highlight geometry function. And finally, this is what the result would look like. And on the left, you can see how the SQL Query window looks like. So let's go ahead and do these steps in iDesktop.
Right. So for our SQL Query exercise, we're going to be using our world dataset here. Let's open it up. And now that we have it open, we're going to go under Spatial Analysis, and this time we're going to select SQL Query. Now here we will have our world dataset selected, and in the fields we are going to select the steric field, and this means that it will be looking in all of the fields contained in this dataset. So we're going to double click on this, and the select text box is going to show world.steric. Right, so in the where, we're going to give it our condition, which is going to be according to our population, because we want to select the countries whose population is greater than or equal to 100 million people. So we're going to say pop underscore 94, and we're going to delete the default expression here, and we're going to say greater than or equal to 100 million. Next, we're going to sort this as well, and we're going to select our world pop 94, and let's say we want this in descending order, and we're going to highlight these on the map, and we're going to save the results as well, and we're going to say OK. So there we have it. All the countries with the populations that are more than 100 million people have been highlighted on the map, and their attribute tables have been created, and we can see all the populations of these countries. They start with the largest. Please keep in mind that this is from the 1994 data, so it is not reflective of current population numbers. So it starts with the highest number and goes in a descending order to the lowest one. Now let's open this up in a new map window so that we can see them separately. So there we have it. We can close the attribute table for now, and we can right click on it and say associate attributes. So you can see that we can browse through them from the associated table. So this is how you run a SQL query. Right, so this is our final task, which is related query. And in this task, we're going to link a table and then run an SQL query, and it is going to be called linked table SQL query. So we're going to query data from more than one table based on the relationship between certain fields in these tables. We have two data sets. We're going to combine them according to a specific field, and then we are going to run a SQL query on them. Now this is the combine stage, where we will combine them using the SMID field, and it is going to be the inner join, which combines two data sets based on a specified field. We're not going to use the other join type because that join type combines all fields regardless of what the fields are in both data sets. So we're going to be using inner join, and we're then going to run this SQL expression. We're going to select some fields from both data sets, and then we're going to say that from these selections, we want to select wherever this age group, the number of people in this age group is greater than 10,000. So let's go ahead and demonstrate that. So for this task, we have our query data source, and we have our polygon data set open, and we're going to select this and go under spatial analysis, and we're going to say SQL query. So there we have it. So the first step is to link these two data sets. Now this is a polygon dataset. It has some attributes, but this one is just an attribute table. It has no related polygon line or point dataset with it. So we're going to relate this with this polygon dataset. So in order to do that, we're going to say set associated field, and here we're going to add our age table, and in the related field, we're going to select the same field that we have here, which is SMID. We're going to say SMID. And now when we click on expression, it is going to automatically fill in the required expression. And we're not going to use left join because we want a specific field. So we're going to say inner join and we're going to say OK. Now this allows us to see fields from both data sets. So these are the new fields that have been included here. So let's fill out our expression. So we're going to say select name, state name, 99 population, which is here. Then we need our age groups, which are 517 and 1829. And now here we're going to say 1829 greater than 10,000. So that is our entire expression. So let's say we're going to highlight this on the map and we are also going to save the result, and we're going to say okay. So there we have it. The attribute table has been created as expected, and we have our states selected where the number of people in the age group 18 to 29 is more than 10,000. So we can open it up in a separate map and take a look. So those are the states there. So this is how you run a linked table SQL query. Now our final step is to save this as a data set. So we're going to go under attribute table and we are simply going to say save as data set. But the thing is that we have already saved it, and we're going to reverse that. We're going to remove this and we're going to rerun our query here. We're going to say spatial analysis, SQL query, and set associated field, add htable, SMID, auto expression, inner join, okay. Save everything. So we're going to highlight it on the map and we're not going to save it though. So we're going to say okay. So it's highlighted and we can select our attribute table here, and under this we have the dataset option, and we're going to save it as region, and we're going to say okay. So here's our new dataset with everything exported, and we can also see its associated attributes, which are here. So that's how you save a dataset. Right, so that's it for today's tutorial on queries in SuperMap. Please practice what we have done here so that you have a deeper understanding of the functions. If you have any problems, please consult the help document or talk to us directly. Thank you.